Dear students, the last session we discussed about the network analysis. What is a network? What do you mean by project management? And different phases of project management, and also how to construct a network diagram. Okay, so today in this session we will discuss about the critical path method. So before going into that, let's see what is a critical path. Okay, the critical path of a project network is the longest path in the network. This can be identified by simply listing out all the possible paths from the start node of the project to the end node of the project, and then selecting the path with maximum sum of activity times on the path. Okay, so here they are talking about the longest path. Critical path means basically the longest path. Now consider this example. This is the last example that we discussed. Here you have the starting node is 1 and the ending node is 9. So there are different paths to reach 9, yes or no? So from 1 to 2, 2 to 5, 5 to 8, 8 to 9. That is one path. Then 1 to 3, 3 to 6, 6 to 8 and 8 to 9. That is another one. 1 to 3, 3 to 4, 4 to 6, 6 to 9. 1 to 3, 3 to 6, 6 to 9. Then 1 to 4, 4 to 7, 7 to 9. And there are a lot of other paths as well in order to reach from 1 till 9. That is from the starting node till the terminating node. Okay, so here in critical path method, we are going to find out the longest path or the critical path in the given network. Okay, so in order to find the critical path, there are two things that we need to find out. That first one is the earliest start time, or the ES. In some textbook it is written as E. And in the second one is the latest completion time, or LC. In some text it is written as capital letter L. Okay, so we need to find the earliest start time and latest completion time. So for determining the earliest start time, we say it is the forward pass, and finding the latest completion time is called as the backward pass. Okay, only if we know these two things we'll be able to find out the critical path of a given network. Okay, now take the case of the first example that we have already discussed in the last session, that is consider the details of a project as shown in the table. So the activity is given, immediate predecessors is given, and the duration is given. And here in the question it was asked to construct a Cpm network, determine the critical path and project completion, compute total floats, free floats for non-critical activities. So construction of Cpm network is already done. We have completed this the first session, okay, in the last class. So now consider that network. Okay, so this is the network. I have drawn it in a fresh page. So you have first activity, first node till 9th node, and all the activities and duration is shown in the diagram. So this is our network diagram. Now what we need to find out is we need to find the earliest starting time and the latest completion time in order to find the critical path. So to find earliest start time, we have a formula. The earliest start time is given as ESJ is equal to maximum of ESI plus duration. Okay, ESJ means earliest start time of the ending activity. It is given by the formula maximum of earliest start time of the starting activity plus the duration of that particular activity. So now let's see how we will find for each and every node. Now you have to remember one thing. In any network diagram, the starting node or the first node, the earliest start time will be 0. So ES1 is always 0 for any network or any given network. That is the first node, the earliest start time is 0. So we are starting from 0. Now let's go to the next node, ES2. Okay, that is for the second node. Now we can see from first node till second node there is only one activity, that is A. Correct? So according to the formula, it is ES1 plus duration of the activity, that is 2. So what is ES1? ES1 is 0. So 0 plus 2 is 2. So ES2 is 2. Then ES3, that is for the third node. So third node also there is only one activity. Preceding activity is just one, that is B. So that is equal to ES1 plus the duration of activity B, that is 5. So that is 0 plus 5, that is 5. Then ES4, that is the fourth node. Now here you can see that there are two activities, that is C and D, which is coming to node number 4. So there are two preceding activities. So here you have to use this formula, that is maximum of, so the first one is ES3 ES3 plus duration of activity D, that is 5. ES3 is given as 5. So that is 5 plus duration of D is 5. So 5 plus 5, comma. Then ES1, that is 0. 0 plus duration of activity C is 4. So 0 plus 4. Okay. So that is maximum of 5 plus 5 is 10. Then 0 plus 4 is 4. So which is maximum, 10 or 4? So this is 10. So ES4 is equal to 10. Then the next one is ES5. That is the fifth node. Here also there is only one preceding activity, that is E. Therefore it is ES2 plus duration of E is 7. What is ES2? ES2 is 2. 2 plus 7 is 9. Then the next one is ES6 for the sixth node. Now here you can see there are three activities, F, G and H. These three activities are the preceding activities. So again you have to use this formula, maximum of ES2 plus F, duration of F. ES2 plus F. What is ES2? ES2 is 2. So 2 plus duration of activity F is 3, comma. Then ES3. ES3 is 5 plus duration of G is 3, comma. Then ES4. ES4 is 10 and duration of H is 6. That is 10 plus 6. So which is the maximum value? Here 2 plus 3 is 5. 5 plus 3 is 8 and 10 plus 6 is 16. So the maximum value is 16. So ES6 is 16. Then the next one is ES7. ES7. So ES7, that is again only there is one preceding activity, that is I. Therefore it is ES4 plus duration of I is 2. So what is ES4? ES4 is 10. 10 plus 2 is 12. Then ES8. ES8, there are two preceding activities. Therefore that is maximum of ES5. ES5 is 9. That is 9 plus duration of J is 5. 9 plus 5, comma. ES6 is 16. 16 plus duration of K is 4. So 16 plus 4. Okay. So here 9 plus 4 is 14. 5 is 14. 16 plus 4 is 20. The maximum value is 20. Then finally you have ES9. ES9, you can see three activities are the preceding activities. So maximum of ES8 is 20. 20 plus duration of N is 8. So 20 plus 8, comma. Then ES6 is 16 plus duration of L is 3. So 16 plus 3, that is 19, comma. Then ES7. ES7 is 12. 12 plus duration of M is 12. 12 plus 12, 24. So you have 28, 19 and 24. So 28 is the maximum value. So here you have ES1 till ES9. Now what you need to do is, here you can draw two boxes here near every node. Near every node you need to draw two boxes. Why? Because the first one, the lower box will represent the ES value, that is early start time, and the upper box will represent the latest completion time. Now ES1 is 0, ES2 is 2, then ES3 is 5. Where is ES3? ES3 is 5. Then ES4 is 10, ES5 is 9, ES6, you need to draw one more box. So you have one more box here. Okay, ES6 is 16. ES7, it is 12. ES8 is 20. And ES9 is 28. Okay. Now the second step is to find the latest completion time. So again you have a formula, LC of I is equal to minimum of LCJ minus Dij. LCI is equal to minimum of LCJ minus Dij. So here every time we need to start from the last node. That means this is the 9th node, right? 9th node is the ending node for this particular problem. So we need to start from the 9th node. Earliest start time and latest completion time of the last node will be the same. So here we found that in this problem the early start time of the 9th node is 28. Correct? So we got it as 28. So latest completion time for 9th node will be same as that of the early start time. So that is equal to 28. So for each and every node you need to find the latest completion time. So for the 8th node, according to the formula, that is equal to minimum of latest completion time of the last activity, that is the 9th node, LC9 minus duration. So you can see that from this diagram we can understand. So 8th node is equal to LC9 minus duration. Duration is 8 minus 8. Okay. So what is LC9? That is 28. 28 minus 8 will be equal to 20. So LC8 will be 20. Now LC7. Now we can see LC7 for the 7th node. 7th node, there is only one activity from 9, right? So that is M. So LC9 minus duration of M, that is 12. So that is 28 minus 12. 28 minus 12 is equal to 16. Then LC6. The next one is LC6. For the 6th node, you can see there are two activities, K and L. One is coming from 8 and one is coming from L. So you have to apply this formula. Minimum of LC6 is equal to minimum of 28 minus 8. Sorry, 28 minus 3. 28 minus 3, that is activity M3, activity L. So 28 minus 3, comma, then 20 minus 4. So you will get it as 16. 28 minus 3 is 25 and 20 minus 4 is 16. Then the next one is LC5. LC5, that is the 5th node. 5th node you have only one activity. So LC8 minus 5. So LC8 is 20. 20 minus 5, which is equal to 15. Then the next one is 4th node, that is LC4. Here you have again two activities, one coming from 6, that is H, and one coming from 7, that is I. So you have to write minimum of 16 minus 6, comma, 16 minus 2. Correct? That is 6 and not 16 minus 2, this is 12 minus 2. Sorry, 12 minus 2. So finally you will get the answer as 10. In case of the 3rd node, that is the 3rd node, you have two activities, that is one coming from 6 and one coming from 4 also. So LC6 minus 3 and LC4 minus 5. So you will get 16 minus 3, comma, 10 minus 5. The minimum of that will be 5. Okay. Then LC2, in case of LC2, this is minimum of 15 minus 7, comma, 16 minus 3, which is equal to 8. Why? Because in case of 2, you have two activities, one from 5 and one from 6, two activities. Okay. And then last one is LC1. Again, you have minimum of, there are 3 activities coming up. So 8 minus 2, comma, 5 minus 5, comma, 10 minus 4. Okay. So that is 0. Here you have 3 activities, one from 2, 3 and 4. So finally you will get the minimum value as 0. So this also, all these values, LC values, you can write here. In case of 1, the first one is 0. 0. Then LC2. LC2 is 8. Then LC3 is 5. So again here you have 5. Then LC4 is 10. LC4 10. Then LC5 is 15. So LC5 15. LC6 is 16. 16. LC7 is again 16. Then LC8 20 and LC9 you have 28. So here you can fill this. So thus you have all the ES and LC values. This lower one is the ES value and the upper one is the LC values for each and every node. Now how you will find out whether the given path or which one is the critical path. Okay. After writing down all the ES and LC values, now you need to find the critical path. Now these are the condition for critical path. ESI is equal to LCI. That is ES and LC values should be equal. Then ESJ and LCJ values should be equal. That is, ESI means the early start time of the starting node and latest completion of the starting node should be same. Early start time of the ending node and latest completion time of the ending node should be the same. Then ESJ minus ESI is equal to LCJ minus LCI, which is equal to the duration. That is ESJ of the starting ending node. For example, if you consider this third node, what is the ESJ value? ESJ value of the third node is 5. 5 minus ESI of the starting node, that is 0. 5 minus 0 is, right? So that means this condition is satisfied. How many of these nodes or activities are satisfying all these conditions? Now you can see in the first node, LC and ES values are same. Then in the third node, these two values are same. Fourth node also these values are same. Then sixth node again these values are same. Then you go to 8th node, again the same values, and 9th node also same values. But if you look at the second node, this is different. 5th node is different. Then 7th node it is different. So here you can see 1 to 3, 3 to 4, 4 to 6, 6 to 8 and 8 to 9. These values remain same. And again if you subtract 20 minus 16, you get 4. Correct? 16 minus 5. Okay, 16 minus 6 you get 10. 10 minus 5 you get 5. And again 5 minus 0 you get 5. So all the three conditions are satisfied. So you can draw two lines here. 1 to 3, then 3 to 4, then 4 to 6, then 6 to 8, and again 8 to 9. So this is our critical path. Therefore, we can write our critical path is 1 to 3, 3 to 4, 4 to 6, 6 to 8 and 8 to 9. 1 to 3, 3 to 4, 4 to 6, 6 to 8 and 8 to 9. This will be the longest path. Now, if you are writing it activity wise, which is the critical activity? 1 to 3 is B, D, H, K and N. B, D, H, K, N. B, D, H, K and N are the critical activities. Okay, these are the critical activities. Now you need to calculate the total duration. So total duration equal to PDHKN. So what is the duration of all this? For B it is 5. 5 plus 6 plus 4 plus 8. 5 plus 6 plus 4 plus 8. 5 plus 5 plus 6 plus 4 plus 8 will give you 28. So it is 28 months, because in the question the duration is given in months. Therefore the total duration is 28 months. So the second part of the question is done. The question is determine the critical path and projection completion time. So projection completion time is 28 months and the critical activity and the critical path is given. Okay, so the second part is clear, I hope. Now we will move on to the third part. The third part they have asked, compute total floats and free floats for non-critical activities. For all the non-critical activity, you need to calculate the total float and free float. Now let's see what is a total float. Total float is the amount of time that the completion time of an activity can be delayed without affecting the project completion time. That means without affecting the total project completion time, how much delay we can make. That is called the total float. It is given by the formula LCJ minus ESI minus duration. So total float is equal to the latest completion time of the ending activity minus earliest starting time of the starting activity minus the duration. So for each and every activity, we need to compute the total float. Okay, so let's calculate the total float. Now, before calculating, we need to draw this table, that is the summary of total float and free float. So in this table you will have all the activities, that is A to N. Then you have the duration, which is already given in the question. These two things are given in the question. Then the another column is for total float and the last column for the free float. So here you have to depict each and everything after computation. Now using this formula, let's calculate total float for each activity. So for first one, that is A, the total float for A, for activity A is equal to LC2, that is here it is LCJ minus ESI, right? So LCJ minus ESI. Now if you take this activity A, the ending node is 2 and starting node is 1. So total float is equal to LC2 minus ES1 minus duration. So what is the duration for A? Duration for A is 2. So you can write 2. So LC2, what is LC2? LC2 is how much? 8. 8 minus 0 minus 2. 8 minus 0 minus 2, which is equal to 6. So for A, the total float is 6. Correct? Then the next one is for B. For B, the activity B, that is LC3, that is 5. 5 minus 0 minus 5. 5 minus 0 minus 5, which is equal to 0. Then for C, activity C, this is 10 minus 0 minus 4. 10 minus 0 minus 4, which is equal to 6. Then for activity D, it is 10 minus 5 minus 5. D is equal to 10 minus 5 minus 5, which is again 0. Then for A, B, C, D, E. So E, it is equal to 15 minus 2 minus 7. 15 minus 2 minus 7, which is equal to 6. Then you have F. Similarly for F, it is 16 minus 2 minus 3, which is equal to 11. Then G, 16 minus 5 minus 3, which is equal to 8. Now look at G. Then H. H is equal to 16 minus 10 minus 6, which is equal to 0. Then I. You have I, 16 minus 10 minus 2, that is equal to 4. Then J. J is equal to 20 minus 9. 20 minus 9 minus 5, which is equal to 6. Similarly, for I, J, K, L, M, N, you need to calculate the total float. So you will get 0, L is equal to 9, M is equal to 4 and N is equal to 0. So for each and every activity, using the formula, we are calculating the float. And now you need to write down each and every value in the summary chart. Okay. So let's write down the values in the summary chart. So total float for A is 6. For B, it is 0. Okay, so now we found out all the total float. Now let's find out what do you mean by free float. Now free float means it is the amount of time that the activity completion time can be delayed without affecting the earliest start time of immediate successor activities in the network. Here we are considering only the earliest start time. Okay, so it is given by the formula free float is equal to earliest start time of the ending activity minus earliest start time of the starting activity minus the duration. Okay, using this formula we are calculating the free float for each and every activity. So A is equal to, A activity is from 1 to 2, correct? So this is, A is from 1 to 2. So according to the formula, ESJ minus ESI, that means these two values. 2 minus 0 minus duration is again 2. So 2 minus 2 minus 0. Sorry, 2 minus 0 minus 2, right? That this is duration, okay? So you will get 0. Then for B, again, if you consider, you have to consider only the earliest start time. So 5 minus 0 minus 5. 5 minus 0 minus 5, you will get 0. Then for C, it is equal to 10 minus 0 minus 4, which is equal to 6. D, 10 minus 5 is equal to 0. E, 9 minus 2 minus 7 is equal to 0. F, so here you consider the activity F. F is 16 minus 2 minus 3. 16 minus 2 minus 3, which is equal to 11. So similarly, for all the rest of the activities, we need to find the free float for all other activities. So finally, we get G is equal to 8, H is equal to 0, I is equal to 0, J is equal to 6, K is equal to 0, L is equal to 9, M 4 and N 0. So you need to write this here in the free float column, right? So A is 0, B is 0, C is 6, D is 0, E is 0, F is 11, then G is 8, H 0, I 0, J is 6, then K is 0, L is 9, M is 4 and finally N is 0. Now look at this total float and free float. So wherever the total float and free float is both 0, then that shows critical activity. Now if you look at B, here total float and free float is 0. So B is a critical activity. Then D is critical activity. Then if you go to H, again a critical activity 0 0. Then wherever here if you take K, that is again a critical activity. Then finally N. Now you can compare this answer with our critical activity value that we got. Okay, so when you can compare that, you can see this B, D, H, K and N are our critical activities. Here also B, D, H, K and N have free float and total float as 0. Fine. So thus we can confirm that our answer is correct. Okay. So the final part of the question, that is to find the total float and free float, is also done. The first step that you need to do in a network analysis is first draw the network diagram. Then you have to mark all the activities and the duration. Then later on find out the early start time and latest completion time. Now condition for critical path is that early start time of the starting activity should be equal to the latest completion time of the starting activity, and early start time of the ending activity should also be equal to latest completion time of the ending activity. And again ESJ minus ESI should be equal to LCJ minus LCI, which is equal to duration. Okay, after marking the critical path, then in the question it was asked to find the total float and free float. Before that you have to find the duration, total duration. By calculating the duration of all the critical activities, you can get the total duration. Then it is about the finding the total float and free float. So I hope the whole idea about this network analysis using CPM is clear to you. Thank you, students.